Homework 15, Exponential Functions, Video 5, Graphing Functions Using Transformations. Because of the time crunch we've been in, we skipped a section prior to test 2 that talked about transformations of functions in general, but we'll kind of touch on them right now. What I have up here is a really jacked up, not jacked up, but dressed up exponential function, f of x equals b to the x. But there's 3 places where I can sprinkle a few things. Number 1, I could sprinkle a negative in front. I could also multiply a number in front, but we're going to skip that transformation. So there may or may not be a negative in front. Number 2, up in the exponent, there may be a number added or subtracted to the x. And number 3, there may be a number added or subtracted at the end of the function. We can also multiply in all the places, in front, up here, in front or up here, but those invoke stretches, which are a little trickier to sketch, so we're only going to look at transformations that move a graph instead of stretch it and change its shape. So what impact will all these different places have? Well, if there's a negative in front, I think most of you know that that reflects the graph across the x-axis. It turns it upside down. We've seen that before with parabolas and absolute values and things. If you add or subtract a number on the x, it's going to cause it to move to the left or the right. A little contrary to what you might think, a plus actually moves the graph to the left, whereas a minus moves the graph to the right. If you add or subtract a number at the end, it's going to move the graph up or down. This one does what you expect. If you add at the end, it moves the graph up. If you subtract it, it moves the graph down. So in summary, negative in front flips it. Plus or minus here moves it left or right, but the opposite of what you would think. Plus or minus at the end moves it up or down, what you would think. So how do we take advantage of that? Well, let's take a look at this particular example. Graph f of x equals 2 to the x plus 1 plus 3. There's a plus 1 in the exponent, and according to this, a plus in the exponent moves it to the left. So we're going to have a transformation where this graph moves to the left 1. But the plus 3 at the end invokes a movement of up 3. So we need to take something and move it to the left 1 and up 3. Well, what is it we need to move? We need to move the graph of the function without the numbers. In other words, we need to take a look at the graph of g of x equals 2 to the x, or whatever you want to call it, equals 2 to the x, and then do that to it. So let's quickly recover what the graph of 2 to the x looked like. I'm not going to put all the points up here, just a few of them. We had a y-intercept at 0, 1. We had a point at 1, 2. We had a point at 2, 4. And we also, well, I'm not going to draw the fraction points back here, but I will keep track of the asymptote, because the asymptote, although it's not part of the graph, it helps define the graph. On some of your graphing questions, it will ask you to graph the asymptote as a dotted line. If you need help with that, please contact me. Speaking of the horizontal asymptote, it is the equation y equals 0, because it's the x-axis, and on the x-axis, all the y values are equal to 0. So how do we draw the new graph? Well, we just do those motions to these points. So let's start with the original y-intercept. We need to move it to the left 1 and up 3. So if I'm here, go left 1 and up 3, it'll put me here. I believe that point is negative 1, 4. Let's take the point 1, 2, move it left 1 and up 3. That puts me at the point 0, 5. And for 2, 4, let's go left 1 and up 3. That puts me here, which I don't have to guess, because if I'm left 1, I'm subtracting 1 from the x. And if I'm up 3, I'm adding 3 to the y. So that point's 1, 7. And we need to keep track of the horizontal asymptote. And moving it left or right doesn't change it, because it goes forever in both directions. But moving it up does. So we need to move this up 3. And the equation of that horizontal asymptote is no longer y equals 0, it is now y equals 3. And then just redraw it. Now in the homework, you're not actually going to be physically moving it. When you click the graph to draw this, you will have some boxes pop up where you can either type how far it moves, or you can move a slider left or right to change the horizontal or vertical displacement. I think it's a fairly intuitive thing to do, but if you need some help, let me know. Now, had there been a negative here, we would have flipped this upside down before we moved it, but it would have still been the same. So graphing an exponential function using transformations is actually not that bad if your transformations are only moving it up, down, left, and right, possibly flipping it over. Again, there are transformations that will stretch it vertically or horizontally, and it's something possible to keep up with, but I've just decided not to explore it.